You open an app, you make a payment, you order something online, you ask an AI a question. It feels like one action, simple, immediate, almost invisible. But behind that single action, something much larger is happening. Systems are communicating. One application requests information, another system processes it. A database responds. A payment network verifies a transaction. A cloud service delivers the result. None of this appears on the screen. Yet without these connections, the modern digital economy would barely function. The internet may look like a collection of websites and applications, but underneath, it is a conversation between machines.
The digital economy is not one giant machine. It is thousands of independent systems. Banks build banking systems. Retailers build commerce platforms. Cloud companies operate computing infrastructure. Software companies build business applications. AI companies build intelligent models. Every organization solves different problems. Every system has different architecture. And yet, businesses cannot remain isolated. A store needs payments. Payments need banks. Banks need software. Software needs cloud infrastructure. Cloud systems need data. Data needs applications. The digital economy therefore creates a permanent requirement. Independent systems must communicate. And that requirement created one of the most important bridges in modern technology. This is where APIs enter the architecture. An API allows one system to communicate with another through defined rules. It creates a structured way for software to request something and receive something in return. That sounds technical, but economically, the idea is much bigger. APIs allow companies to use capabilities they did not build themselves. A business can connect to payments without becoming a bank. An application can use maps without creating a global mapping network. A company can connect to artificial intelligence without building an entire foundation model. The API becomes a bridge, and bridges become valuable when more economic activity needs to cross them. Once software can communicate with software, something changes. The internet stops being merely a place where humans interact with machines. Machines begin interacting with other machines. A customer places an order. Software checks inventory. Another system processes payment. Another updates the database. Another triggers delivery. Another sends a notification. None of these systems needs to understand the entire business. Each one performs a specific function. The API connects them. This creates modularity. Businesses no longer need to build every capability internally. They can assemble systems from specialized components, and that changes the economics of building digital companies.
This is one reason digital businesses can be built differently today. A company does not necessarily need to own every layer of its technology stack. It can combine specialized services, payments from one provider, communication from another, cloud infrastructure from another, analytics from another, artificial intelligence from another. The company becomes an architect of systems. It decides which components belong together, which dependencies are acceptable, which capabilities are strategic, and which should remain external. This is a profound shift. Competitive advantage increasingly comes not only from what a company builds, but from how intelligently it assembles what already exists.
And eventually, the connection itself becomes a business. Companies can provide specialized capabilities through APIs. Businesses pay for access. Developers integrate those capabilities into their products. Customers use the final service without ever knowing which infrastructure sits underneath it. This creates a layered economy. The visible business owns the customer relationship. The infrastructure provider owns a capability beneath it. And sometimes that capability becomes essential. The provider does not need to own the entire application. It only needs to become the system the application depends on. This is how a technical interface can become economic infrastructure.
Now consider the strategic position. If thousands of businesses depend on the same connection layer, that layer can gain leverage, not because it owns the businesses, not because it controls their customers, but because it occupies a critical position between systems. The economics of infrastructure often work this way. The most valuable position is not always at the end of the transaction. Sometimes it is in the middle, the layer that connects demand to capability, the layer that reduces friction, the layer that businesses integrate once and continue using for years. When a connection becomes difficult to replace, the connection itself becomes an asset.
The next advantage comes from scale. One connection is useful. 100 connections are more useful. Thousands can become infrastructure. As more businesses integrate with a digital service, the surrounding ecosystem can become richer. Developers learn how to use it. Businesses design workflows around it. Other services connect to it. New products emerge on top of it. The network becomes harder to ignore. This does not mean every API becomes dominant. Most will not. But the architecture creates a powerful possibility. A small technical capability can become a major economic layer when enough businesses organize themselves around it.
But every infrastructure advantage creates another question: dependency. When a business relies heavily on external systems, those systems become part of its architecture. A change in pricing can matter. A change in availability can matter. A change in technical standards can matter. A change in reliability can matter. This is why serious digital businesses do not simply ask, "Does this service work?" They ask a deeper question: how important will this dependency become? Infrastructure is powerful because it removes complexity, but removing complexity from one place can concentrate it somewhere else. And understanding that trade-off is part of becoming a true system architect.
The modern internet looks like a collection of products, websites, apps, platforms, dashboards, services. But beneath those visible layers is another economy, an economy of connections. APIs allow systems to communicate. They allow businesses to assemble capabilities. They allow software to become modular. They allow specialized infrastructure to serve thousands of companies. And as digital activity grows, those connections become more important. The most powerful infrastructure is often the infrastructure nobody notices, the bridge between systems, the layer beneath the interface, the connection that makes everything else possible. Because the digital economy does not simply run on software. It runs on software that can communicate. And when connection becomes infrastructure, the code between businesses can become just as valuable as the businesses themselves.
The next generation of digital businesses will not always compete by building everything themselves. Many will compete by orchestrating systems, connecting capabilities, reducing friction, and owning the critical layer between them. Because when enough economic activity depends on a connection, the connection stops being technical plumbing. It becomes infrastructure. Nexera. Decoding systems. Architecting wealth.